Over to you, Salima, Miss.
Okay, sir. Respected resource person of the session, Professor Anuroop K B, Adishankara Institute of Engineering and Technology, Kaladi, Ernakulam. Respected Principal Dr. Amira VU, IIC President Dr. Jairam, all the faculty members of the MES Ponnani College and dear students. A very good morning to all. Today, we are in the third lecture of the Impact Lecture Series organized by IIC MES Ponnani College and sponsored by Institution Innovation Council, Ministry of Education, Government of India. For today's session, we have an expert engineer and public speaker, Professor Anuroop K B, as our resource person. For a brief introduction, Mr. Anuroop K B, Assistant Professor of Adishankara Institute of Engineering and Technology, Kaladi. His various positions in the institutions are TBI Manager, IEDC Coordinator, Fab Lab Manager, Vice President of IIC, and Technical Project Consultant. He is an experienced faculty with a demonstrated history of working in the education management and industry, skilled in embedded system design, FPGA prototyping, 3D modeling, entrepreneurship development, and VLSI CAD. He had received grants of more than 60 lakhs worth funded projects from various government agencies. His different areas of expertise include 3D modeling, vector designing, rapid prototyping, 3D printers and scanners, etc. Currently, he is doing his PhD in Indian Institute of Information Technology, Kottayam. He had a number of patents and publications in various inventions in the field of technology. On behalf of IIC MES Ponnani College, I welcome you, sir. I
Thank
welcome
you.
our principal, Dr. Amira VU. Welcome, ma'am. I also welcome all the faculty members and students who are participating in this session. Welcome all. Now I invite Amira ma'am for the presidential address. Thank you. Over to you, ma'am.
Am I audible?
Yes, ma'am.
Okay.
Please.
Respected Chief Guest, Anuroop K B, Dr. Jairam, IIC President, Mrs. Salima, IIC Vice President, faculty members, students, a very good morning to all. Today, as part of Impact Lecture Series, we are having a session on rapid prototyping, limits and possibilities. And as you know, innovation has become the driving force of social and economic development, and the cultivation of innovative talents of students has become the core goal of higher education sector of India. Activities of IIC in educational institution could make some efforts towards creative and at the same time rapid development of the country by bettering the performance of higher educational institutions all over India. In tune with it, innovation cell of our college give the students the opportunity to develop their innovative skills, to work with new ideas and transform them into prototypes while they are in their transformative years. MES Ponnani College is actively involved in the development of an innovative ecosystem within the college and at the same time tries to understand the need of locality too. We are mainly concerned with the commodities suitable for the fisher folks of rural areas of Ponnani as we aim to uplift them both financially and technologically. We believe the Incubation Innovation Center inside the college can play a major role in it. And I'm happy that Dr. Jairam and Ms. Salima are taking great pain for strengthening the activities of IIC and from bringing accolades to our institution. Herein, the session on prototyping is very important to us. For an arts and science college institution, prototyping remains a difficult thing considering its technological aspects. Yet, we realize the importance of rapid prototyping technology as a means to strengthen the cultivation of students' innovation and entrepreneurship ability. As a new visualization technology, the application of rapid prototyping technology in the field of education has attracted the attention of researchers and is bringing innovation in teaching, learning, and research. So a session like this will help to educate both students and faculties in this regard and will throw light on what steps we have to take further. And I'm so happy that we have a very resourceful and learned guest, Mr. Anuroop K B. He is an experienced faculty with a history of working in the education, management, and industry. He's a very good scholar in the field, and his contributions are widely acknowledged. He has been bestowed with many awards too. By getting him as a resource person, I am sure that we are going to have an enlightening session. With due respect, I invite him to deliver the talk. Sir, please.
Thank you, ma'am. Thank you for the introduction. And nice to hear that the college is giving this much importance to innovation and entrepreneurship. So I hope I'm audible.
Yes, sir.
Okay, fine. So in this session, we will start with different aspects of prototyping. I will introduce different machines and different tools for prototyping, both hardware and software tools, and then we will move on to some consultancy projects which we did. We actually created the product for that particular projects, but the first stage was a prototype development. So we'll tell that story also. So we'll start with the prototyping aspects, and then we will move on to the hands-on project section. So Gokul, will you please share the slide?
Sure.
So the slide is visible, right? Slides കാണുന്നില്ലേ?
Yes, it is visible.
Yeah.
Fine.
So let's start with a question. So I wish to know from the audience what exactly is the difference between innovation and invention. Audience, you can put it in the chat box, or you can unmute yourself and tell. The question is, what is the difference between innovation and invention? Anyone? The difference between innovation and invention. എന്താണ് innovation and innovation അല്ലെങ്കിൽ invention? എന്താണ് അത് തമ്മിലുള്ള വ്യത്യാസം? So what exactly is the difference? Anyone can put it in the chat box, or you can unmute yourself and speak. So I hope I'm audible. We have around 60 participants, right? Anyone? 87 participants. Okay, very good. Okay, fine. Please. Innovation and invention. What is innovation? Or what is invention? Anyone? So I'm audible, right? Am I audible?
Yes, you're audible.
Okay.
Yes, you're audible.
Anyone?
So students, please participate actively. We can have an interacting session then.
Yeah, true. So then only I'll be able to discuss more about the topics which you don't know. So we'll have to focus at some place, right? A simple question. What is innovation, or what is invention? If you don't know the difference, leave that. Just tell me what is innovation and what is invention. Okay. So not getting a response. So okay, fine. So we'll talk about invention first. So invention is creation of something new and meaningful. Invention is to create something new and meaningful. So that's invention. So I hope you guys know about invention. A lot of inventions are happening around us, and you guys know about invention. So that's the definition: creation of something new and meaningful. And what about innovation? So the innovation should have some commercialization potential. So that's the difference between invention and innovation. If it is a simple invention, the commercialization potential is not that important. It should be something meaningful. It should be something new. That's it. That's a simple invention. But when we are speaking about innovation, somebody should have to use it. It should be beneficial to someone. So there should be some commercialization potential. So you can call it as a invention times commercialization potentials is innovation. Innovation is invention times commercialization potential. So I'll explain once more. In case of a normal invention, it should be something new and meaningful. But when we are coming to innovation, it should be something usable. It should have some value. It should have some commercialization potential. So that's the basic difference between innovation and invention. So what we are trying to learn is how to do the innovation process. So how to innovate, and prototyping is coming under this innovation actually. So it's a step under innovation. So how to innovate? That's the next question. So how can you do innovation? Is there any shortcut for doing innovation, or is there any steps for doing innovation? Anyone? Is there any procedure to do innovation? Okay, fine. Leave that. What we are going to talk about today is we'll talk about innovation, the process of innovation. Then we will move on to a step. It's a step means prototyping. It's coming under a step, coming as a step under innovation. So we'll talk about prototyping as well. So let me start with innovation process. Can we move on to next slide? Okay. So design thinking. So you will have to follow in this era. You will have to follow design thinking approach for successful innovation. So by following design thinking, you can become a very good innovator, a successful innovator. So what exactly is design thinking? Design thinking is an advanced problem solving approach as per the definition. So it's a practical and creative problem solving approach. So it focuses on understanding others' need. So it's a multi-step process. So we will discuss about design thinking process. Next slide. So anyone from the audience, can you tell me what exactly is this in the slide? So who's gonna tell me this? What exactly is this? Any idea about this image? Anyone? Anyone?
Virtual reality play system ആണ്.
It's not a virtual reality basis.
It's a scanning for kids.
Yeah, very good. It's a scanning for kids, scanning room for kids. എന്തുകൊണ്ടായിരിക്കും അത് ഇങ്ങനെ ഒരു രീതിയിൽ ഡിസൈൻ ചെയ്ത് വെച്ചിരിക്കുന്നത്? What will be the reason? It's something different compared to the traditional scanning rooms, right? So why this difference? Why they did this? എന്തുകൊണ്ടായിരിക്കും ഇങ്ങനെ ചെയ്തിരിക്കുന്നത്? Anyone?
Maybe students attract ചെയ്യാനായിരിക്കും.
Yeah. Yeah, very good. So that's the right thing. So the main thing is, so when we go to a scanning room, even the adults are scared of the atmosphere. So it's a scary feeling. So നമ്മൾ ഒരു സ്കാനിങ് റൂമിലേക്ക് കയറി ചെല്ലുമ്പോൾ അഡൾട്ട്സ് ആണെങ്കിൽ പോലും there will be a scary feeling in our mind. So there will be an alien experience. So what about the kids? The kids will be facing the same thing, right? So to avoid that, they came up with this particular design. So the kids will be familiar with that atmosphere. The kids will be familiar with the cartoon characters. The kids will be familiar with the drawings and all those things. So this will reduce the alien feeling. This will reduce fear, so that the kids will be comfortable inside the scanning room. So that's the advantage of these kind of scanning rooms. So this is a perfect example of design thinking. സോ ഈ ഒരു പ്രോഡക്റ്റ് എവിടെ നിന്നാണ് വന്നത്, ഇതിന്റെ ഉത്ഭവം എവിടെ നിന്നാണ്? ഈ പ്രോഡക്റ്റ് ഉണ്ടായത് ഫ്രം ഫ്രം ദ തോട്ട് പ്രോസസ് ഓഫ് എ കിഡ്. ഒരു കുട്ടിയുടെ തോട്ട് പ്രോസസ്സാണ്. കുട്ടിക്ക് ഒരു സ്കാനിങ് റൂമിലേക്ക് കയറുമ്പോൾ പേടി തോന്നുന്നു. സോ when a kid enters a scanning room, he will feel scared. Definitely he will feel scared because of the alien nature of that particular room. ഈ ഒരു പേടി കുറയ്ക്കാൻ വേണ്ടിയിട്ടാണ് ഈ ഒരു പ്രോസസ്സ് ഉണ്ടായത്, ഈ ഒരു പ്രോഡക്റ്റ് ഉണ്ടായത്. ഈ ഒരു പ്രോഡക്റ്റ് ഉണ്ടാക്കിയെടുത്ത ഒരു സ്റ്റെപ്പ് ഉണ്ട്, സീരീസ് ഓഫ് സ്റ്റെപ്പ്. ഈ ഒരു പ്രോസസ്സിനെയാണ് ഡിസൈൻ തിങ്കിങ് എന്ന് പറയുന്നത്. ബേസിക്കലി സ്പീക്കിംഗ്, യു വിൽ ഹാവ് ടു see through others' eye. That's it. You will have to put others through. You'll have to think like that. You'll have to think about others. You'll have to think about others' point of view. So that's a basic procedure for design thinking. So next slide. So design thinking process. So you'll have to start from empathize. You'll have to then define, then ideate, prototype, and test. Empathize. So that's the important step. Empathize. ഇതാണ് ഞാൻ നമ്മളുടെ ഒരു സ്കാനിങ് റൂം കാണിക്കാൻ കാരണം. എംപതൈസ്, ഇറ്റ്സ് എൻ ഇമ്പോർട്ടൻറ്റ് സ്റ്റെപ്പ്. ഇറ്റ്സ് എ വെരി ഇമ്പോർട്ടൻറ്റ് സ്റ്റെപ്പ്. എംപതൈസ് ബിക്കോസ് നമ്മളായിട്ടല്ല ഒരു പ്രോബ്ലം കണ്ടുപിടിക്കണമെങ്കിൽ നമ്മളായിട്ട് നിന്നാൽ പറ്റില്ല. യു വിൽ ഹാവ് ടു തിങ്ക് ഫ്രം അതേഴ്സ് പോയിന്റ് ഓഫ് വ്യൂ. ഇപ്പൊ ഒരു കുട്ടിയുടെ മനസ്സിൽ കയറി, അല്ലെങ്കിൽ ഒരു കുട്ടിയുടെ കണ്ണിലൂടെ നോക്കിക്കണ്ട് ചിന്തിച്ചപ്പോഴാണ് ഈ ഒരു പ്രോബ്ലം വന്നത്, അതിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ഒരു സൊല്യൂഷൻ വന്നത്. ആ ഒരു കോൺസെപ്റ്റിനെയാണ് എംപതൈസ് എന്ന് പറയുന്നത്. മറ്റുള്ളവരുടെ പോയിന്റ് ഓഫ് വ്യൂവിൽ നിന്ന് നോക്കുക. യു വിൽ ഹാവ് ടു തിങ്ക് ഫ്രം അതേഴ്സ് പോയിന്റ് ഓഫ് വ്യൂ. യു വിൽ ഹാവ് ടു ലുക്ക് ത്രൂ അതേഴ്സ് ആയി. അതാണ് എംപതൈസ്. അത് ഈ ഒരു പ്രൊഡക്റ്റ് അല്ല, ഏതൊരു പ്രൊഡക്റ്റ് ആണെങ്കിലും ആ ഒരു പ്രോബ്ലം ഡെഫിനേഷന് നമ്മളെ ഏറ്റവും സഹായിക്കുന്നത് എംപതൈസ് ആണ്. എംപതൈസ് വേറൊരു ആൾക്കാർ അനുഭവിക്കുന്ന ബുദ്ധിമുട്ട് കുറയ്ക്കുമ്പോഴാണ് ഒരു സക്സസ്ഫുൾ പ്രോഡക്റ്റ് ഉണ്ടാവുന്നത്. ഇപ്പോ ഫോർ എക്സാമ്പിൾ സ്വിഗ്ഗി എന്ന് പറഞ്ഞൊരു ആപ്ലിക്കേഷൻ എങ്ങനെയാണ് ഇത്രയും ഹിറ്റ് ആയത്? നമ്മൾ കടയിൽ പോയി അത് സാധനങ്ങൾ വാങ്ങിക്കൊണ്ടുവരിക, ഫുഡ് വാങ്ങിക്കൊണ്ടുവരുന്നത് ഇറ്റ്സ് എ ഹെക്ടിക് ടാസ്ക്. സംടൈംസ് ഇറ്റ് വിൽ ബി ഡിഫിക്കൽട്ട് ഫോർ അസ്. ആ ഒരു പ്രോബ്ലം സോൾവ് ചെയ്തപ്പോഴാണ് അവർക്ക് ഒരു സക്സസ്ഫുൾ പ്രോഡക്റ്റ് ഉണ്ടായത്. അതുപോലെ നമ്മളുടെ യു പി ഐ ആപ്ലിക്കേഷൻസ് എന്തുകൊണ്ടാണ് ഇത്രയും സക്സസ്ഫുൾ ആയത്? അത് നമ്മളുടെ ഒരു മേജർ ഇഷ്യൂ റെഡ്യൂസ് ചെയ്തു. ബാങ്ക് ട്രാൻസ്ഫേഴ്സും കാര്യങ്ങളും ഭയങ്കര ഹെക്ടിക് ആണ്. അത് കുറച്ചപ്പോൾ നമ്മൾക്ക് ഒരു സക്സസ്ഫുൾ UPI ആപ്ലിക്കേഷൻ ഉണ്ടായി. സോ ദാറ്റ്സ് അഡ്വാൻറ്റേജ് ഓഫ് എംപതൈസ് പ്രോസസ്. മറ്റുള്ളവരുടെ പ്രോബ്ലംസ് മനസ്സിലാക്കുക, ആ ഒരു ഫേസ് ഇമ്പോർട്ടന്റ് ആണ്. സോ ദാറ്റ്സ് എ ഫസ്റ്റ് സ്റ്റെപ്പ് ഇൻ ഡിസൈൻ തിങ്കിങ്. സോ വൺസ് യു ആർ ഡൺ വിത്ത് എംപതൈസ് ഫേസ്, you will understand the problem. You will be able to figure out some problems, or you will be able to sort out some problems. So it's ready. We are ready with the problem observation or finding the problem. Then you will have to define that problem in define phase. എന്താണ് ഡിഫൈൻ ഫേസിൽ വരുന്നത്? നമ്മൾ കണ്ടുപിടിച്ച ആ ഒരു പ്രോബ്ലം പ്രോപ്പറായിട്ടും വ്യക്തമായിട്ടും മറ്റുള്ളവർക്ക് മനസ്സിലാവുന്ന രീതിയിലും ഡിഫൈൻ ചെയ്യുക. യു വിൽ ഹാവ് ടു ഡു എ പ്രിസൈസ് ഡിസ്ക്രിപ്ഷൻ ഓഫ് യുവർ പ്രോബ്ലം. എന്തുകൊണ്ടായിരിക്കും പ്രിസൈസ്ലി അത് ഡിസ്ക്രൈബ് ചെയ്യണം എന്ന് പറയുന്നത്, പ്രിസൈസ്ലി ഡിഫൈൻ ചെയ്യുന്നതെന്ന് പറയുന്ന കാരണം എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, നമ്മൾക്ക് ഒരു പ്രോബ്ലത്തിന് ഒരു പേജായിട്ട് എഴുതാം, അല്ലെങ്കിൽ ഒരു പ്രോബ്ലത്തിന് 10 പേജായിട്ട് എഴുതാം. That's not the right way. That's not the right way to define a problem. It should be very, very precise. ഒരു 1-2 സെന്റൻസ് കൊണ്ട് മറ്റുള്ളവർക്ക് മനസ്സിലാവുന്ന രീതിയിലായിരിക്കണം ആ ഒരു പ്രോബ്ലം നമ്മൾ ഡിഫൈൻ ചെയ്യേണ്ടത്. സോ ദാറ്റ്സ് ഇമ്പോർട്ടൻസ് ഓഫ് ഡിഫൈൻ ഫേസ്. സോ യു വിൽ ഹാവ് ടു മേക്ക് യുവർ പ്രോബ്ലം ഡെഫിനേഷൻ പ്രിസൈസ്. It should be precise. So it will be very easy to convey that particular problem to others. So the define phase is important. Then comes the ideate phase. During this ideate phase, you will have to find solutions. You will have to find different solutions for the problems. There will be n number of solutions for a particular problem. So you will have to list down different types of solutions. Multiple solutions can be formulated at this stage, the ideate stage. So once you have a problem solution, you can create a prototype of that particular solution. So why we are using prototype? So once the problem is ready, you will have to create a prototype. Why we are using prototype? The prototype is used to deliver your idea effectively. If there is a prototype, you can show it to others. So here is my prototype. This is working. So it will be very easy to convey your idea to others and take feedbacks. So that's the importance of prototype. So when you're writing your solution in a paper and you're giving it to someone, so that's not an effective way to deliver something. So if you have a prototype, it will be very effective, and the evaluators or your mentors, your guides, your friends can give suggestions on that particular prototype. It will be very easy to convey your idea. So that's the advantage of doing prototyping. So another advantage is that you can do field tests using prototyping. You can take your prototype to your field and do the field trials using prototype. So that's the advantage of using prototyping. Can we move to next slide? Next slide. Next slide. So these are the definitions of the empathize, ideation, and then comes to prototyping. So please, next slide. Okay. So who's going to tell me this? What exactly is displayed in the screen here? Anyone? Anyone from the audience? What is this? So we were discussing about prototypes. So we started from empathize, then came to ideation, then we came to prototyping. So now we are speaking about prototypes. So based on that, what will be this? Anyone from the audience? Okay, so it's a simple prototype. It's a simple prototype of a smartwatch. ഒരു സ്മാർട്ട് വാച്ചിന്റെ സിമ്പിൾ ആയിട്ടുള്ള ഒരു പ്രോട്ടോടൈപ്പ് ആണ് കാണുന്നത്. പെൻ ആൻഡ് പേപ്പർ വെച്ച് ഉണ്ടാക്കിയിരിക്കുന്ന പ്രോട്ടോടൈപ്പ് ആണ്. അതിൻ്റെ അകത്ത് ആ സ്മാർട്ട് വാച്ചിൽ വരുന്ന ഓരോരോ സ്ക്രീനുകളും അതിൽ കാണിച്ചിട്ടുണ്ട്. സോ ഇറ്റ്സ് എ സിമ്പിൾ പ്രോട്ടോടൈപ്പ് ഓഫ് എ സ്മാർട്ട് വാച്ച്. സോ ഐ ഹോപ്പ് തിങ്സ് ആർ ക്ലിയർ. സോ ഇങ്ങനെ ഒരു പ്രോട്ടോടൈപ്പ് ഉണ്ടെങ്കിൽ യു ക്യാൻ ഡെലിവർ യുവർ ഐഡിയ എഫക്റ്റീവ്ലി. സോ ദാറ്റ്സ് അഡ്വാൻറ്റേജ് ഓഫ് യൂസിങ് എ പ്രോട്ടോടൈപ്പ്. സോ ഐ ഹോപ്പ് ദിസ് ഇസ് ക്ലിയർ. സോ പ്രോട്ടോടൈപ്പ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഒരു ഭയങ്കര വലിയ സാധനം ഉണ്ടാക്കി വെക്കലല്ല. If you are able to deliver your idea effectively using a simple pen and paper or a simple craft work, then you can call it as a prototype. Okay, next slide, please. So, what about this? So, this is in the previous slide, we saw a prototype of a smartwatch. This is also a prototype of smartwatch, but there are some difference. So who is going to point out that? നേരത്തെ കണ്ട പ്രോട്ടോടൈപ്പും ഈ ഒരു പ്രോട്ടോടൈപ്പും തമ്മിൽ എന്താണ് വ്യത്യാസം? രണ്ടും സ്മാർട്ട് വാച്ചിന്റെ പ്രോട്ടോടൈപ്പ് ആണ്. Any idea? Anyone?
This may be a working model.
Yeah, very good, very good. So ഇതിനു മുന്നേ കണ്ട പ്രോട്ടോടൈപ്പ് was just a pen and paper work. It's not a working model, it's just a demonstration. So it's a demonstration of that particular smartwatch application. So coming to this is a working model. So there are some difference between the first prototype and second prototype. It's a degree of closeness to the final product. Degree of closeness to the final product. In the first prototype, the degree of closeness to the final product was minimal, and in the second prototype, the degree of closeness to the final product is high. Can we move on to the next slide? Yes. So these are the difference. Okay, the main difference. So first one is a low fidelity prototype, which means the degree of closeness to the final product is low. And in the second case, we are having high fidelity prototype, and the degree of closeness to the final product is high compared to the first one, and we are calling it as a high fidelity prototype. So these are the two main prototype types: the low fidelity prototype and the high fidelity prototype. So both are effective. Both the prototypes are effective way to convey your ideas. So when you're going for a idea pitching, when you're going for a presentation, when you're going for a hackathon, try to create at least a low fidelity prototype. So your chance of getting to the final stage will be maximum. So you can easily impress the judge using a low fidelity prototype or high fidelity prototype. If it's not possible to create a high fidelity prototype, just move on with the low fidelity prototype. Both of them are effective way to convey your ideas. So moving on. So we'll start with prototyping. So we learned about prototyping. We learned about design thinking. We learned about why prototyping is important. We learned about different types of prototypes, and now we are moving on how to prototype. So how to create a prototype. So basically, we have two types of products. First one is a hardware software based product. Next one is a pure software based product. Or the third one is pure hardware based product. So here we are not talking about pure hardware based product. We'll be discussing about pure software based products and pure hardware and software based products. Okay. So how to create a software prototype? How to create a software prototype? So I will tell you some examples of some pure software application. For example, Swiggy. Swiggy is basically a software application. Facebook is a software application. Instagram is a software application. So before designing Facebook, before designing Instagram, before designing Swiggy, they might have created a prototype, right? So that will be the process. They will start with a prototype. Then they will move on to the implementation. So why we are using prototypes? You can take your prototype to an investor. You can take your prototype to a pitching panel. You can take your prototype to your mentor. So that's why we are using prototypes. Basically, MNCs will make a prototype and then they will attract some investors. And in some other case, some startups will create a prototype and they will try to attract some investors and funding. So that's why that's why the prototyping is important. So now we are talking about pure software prototypes. For example, a mobile phone application or a website. So how to create a website prototype, or how to create a mobile phone application prototype of a mobile phone application. So which software will you use? There are a lot of softwares available in the market. First one is Fluid UI. It's an open source version. Using Fluid UI, you can create a prototype of websites and mobile phone application. So another one is Adobe XD. The screenshot of this is a screen layout of an Adobe XD. So using Adobe XD, you can create software prototypes of web applications as well as mobile phone applications. It's a very, very useful tool, and you can create high quality prototypes using Adobe XD, which is very, very similar to the actual website. So when you're next time when you're going for an idea pitching, or next time when you're going for a hackathon, you can, if you are designing, your target is to design a software project, or your aim is to design a software application, then definitely you will have to try Adobe XD to create a wonderful prototype. But it's very simple. So you don't need to do a 3 months course for learning Adobe XD. Everything is available in Google. You just do a minimal Google search, and you will be able to design a prototype using Adobe XD. No programming needed. Zero programming knowledge is needed. You can create an excellent prototype of your platform using Adobe XD. So moving on. So now we are moving. That's all about software prototyping. You can use Fluid UI or Adobe XD, and there are tons of open source platforms available. You just go and Google. So these two are important because most of the designers are using Adobe XD and Fluid UI for their software prototyping needs. Now we are moving on to the hardware side or hardware software side. Okay, so I hope you guys know about 3D printers. So if you wish to create a mechanical part, if you wish to print a part, so here is an example. So in the right side there is a jet engine which is designed using a 3D printer. It's a fully 3D printed jet engine, not a simple 3D printer like this. It's printed using a metallic 3D printer. So what exactly is 3D printing? Any idea about 3D printing? So if you guys know about 3D printing, so it will be easy for me. Otherwise, I will explain from scratch. Any idea about 3D printing?
No idea, sir, please.
Okay, fine. So can you play that video? So this is a 3D printing procedure. This is a 3D printing procedure. You can just look at this. This is a 3D printer, and the 3D printer is printing that object, the Groot. See how the 3D printer is printing. This is a material which is used for 3D printing. I will explain about that. See, the printer is printing that object layer by layer printing. See, the printer is printing it from the base layer to the top layer. So we got a mechanical object. See, so finally this is a final product after 3D printing. So you will get a hardware product just by doing a 3D printing. Okay, so we'll go to please go to the previous slide. So that's all about 3D printing. So what exactly is 3D printing? It's 2D printing done again and again. Assume that I'm going to print something in a white paper using a normal printer. What will happen if I'm printing again and again in same position? So I'm going to print my name, Anuroop. I'm going to print my name, Anuroop, using a simple printer. And I'm going to print that particular name again and again in the same position. Again and again in the same position. So what will happen? It needs some thickness, right? What will happen if you're writing your name again and again in the same position? You will get some thickness. So that's the concept of 3D printing. So we will be printing the base, and we will be printing of that. We will be printing on the top of that. We will be printing on the top of that, and again, layer by layer, we will do the printing, and finally, we will get an entire object. So that's the concept of 3D printing. So we will get the entire object by printing layer by layer.
Sir, how about the internal structures? It will be accurate or the architecture?
So if there is an internal structure, you will have to design it separately, and you will have to attach. For example, if it's a closed structure, you will have to slice the entire structure, or you will have to break down the entire structure to 2 pieces. Then you will have to attach both the parts. So it will be easy for doing the printing process. Otherwise, it will be difficult. If there are internal structures, you will have to take out that internal structure and print it first, then attach it to an outer body. So that's the procedure.
Okay, thank you, sir.
Okay, so that's a concept of 3D printing. So how to 3D print? So which materials you will have to use? For 3D printing, you can use different types of materials. ABS is one material. ABS. Then comes the polylactic acid PLA. So different types of materials can be used for 3D printing. So if you wish to have a very high strength, you can go for ABS. PLA prints will be brittle. So based on the application, you can choose. The PLA prints are low cost, but the ABS prints are high, having very high cost. So different types of 3D printers are available. Different types of technologies used. So in this 3D printer, fusion layer deposition is used. There are a lot of other 3D printers also available. So in this 3D printer, FDM is used. So I hope I'm audible.
Yes, sir.
Okay. So the material uses polylactic acid, and the 3D printer will print layer by layer. So that's a concept of 3D printing. So for doing the 3D printing, you will have to for doing the 3D printing, you will have to model your design in 3D. There are a lot of tools available to model your 3D print. For example, if you wish to print something, you will have to design that. So how to design? You will have to use a software. You will have to use a 3D modeling software for designing your 3D model. So how to use a 3D model? How to design. So next we are gonna I will introduce a tool. So just wait a minute. Hello, I'm audible now, right?
Yes, sir. Please.
Fine. So we'll show you a demonstration on 3D modeling. Since you guys are not aware about 3D printing and all those things, so I will show you a simple demonstration. So this is an online tool available. The name of the tool is Tinkercad, and using this tool you can create your 3D shapes. So we will show you a simple example. So here I'm dragging a simple cube, and you can change the shape of that cube, you can change the dimensions, you can change the height, you can change the orientation. So you can do n number of things using that particular shape, and you can merge with other shape also. I'm going to drag another shape, and you can merge these two shapes to create a 3D model. See, this is a simple example, a very basic example of 3D modeling. So what we're going to do is, when you are creating professional 3D prints or professional 3D models, you can go for Fusion 360 or Rhino. Rhinoceros and Fusion 360 one of the some of the best tools available in the market. So let's move. So that's all about 3D printing. So once you're after modeling, you can 3D print your design. So after modeling, you can just export your file and do a slicing. Slicing means layer by layer splitting of your design. As I said, 3D printing is layer by layer printing. It will print base layer first, then will print top layer, then will print the layer above that particular layer, and then it will print all the layers. So that's the concept of 3D printing. So you will have to export your file and you'll have to slice your file. So for slicing, you can go for any different softwares are available. Cura slicers are available. Open source slicers are available. Then you'll have to put it in the 3D printer. So this session is not restricted to 3D printing only. That's why I'm not explaining 3D printing. For learning 3D printing, you will have to attend a 1 day long session on 3D printing. So you will get a clear idea. So that's all about 3D printing. So now we are moving on to other prototyping aspects. So now we are moving on to 3D scanning. Why we are using 3D scanning? So assume that you have an object which is complicated to design. You have an object which is very complicated to design. So what will we do? You will try to copy that object, right? So how to copy? You can copy that object and do a 3D printing. So how to create a 3D model from an object? Assume that you have to design something which is very complicated, but it is available in your hand. So in that time, how to create a 3D model from that particular object? So how to copy that 3D model? For example, your face. Your face is very complicated to design. So very, very complicated to design your face using a 3D modeling software, similar to that which we demonstrated. It's very difficult to design your face. So how to design your face without actually modeling your face? So how to design something without actually doing the 3D modeling? So there comes the benefits of 3D scanning. So we'll move on to that video. You will get a clear idea about 3D scanning. So you just watch the video. So in his hand there is a 3D scanner. The name of that particular scanner is Sense 3D scanner, and the object is placed in a rotating plane, and you are getting a 3D model. See the left side, you will get a 3D model. So you don't need to go and design that particular face. You will easily get a 3D model from that particular object. You don't need to design it yourself. So you can save a lot of time. So that's why we are calling it as rapid prototyping. You will be able to save a lot of time. Rapid prototyping. So this is the concept of 3D scanning. So let's move on. Now comes the laser cutting. Basically, laser cutters are used for creating hardware prototypes. So you can see a casing of Raspberry Pi which is created using laser cutter. Using laser cutter, you can cut acrylic pieces, wooden pieces, and similar structures, and you can create impressive prototypes using laser cutter. So we will show you a video of laser cutting. So you can see a high power laser pointer is used to create a cut. So actually it is burning the surface. The high power laser is burning the surface. So why we are going for laser cutting? The laser cutting is having very, very high precision. 0.01 millimeter precision, precisely speaking. Most modern laser cutters are having 0.1 millimeters precision. So you wish to create a highly accurate industry level cuts or highly accurate industry level engraving, you have to go for laser cutting. So you can create product casing using laser cutting. Actually, printers can also be used to create product casing. But the laser cutters for big casings, you can go for laser cutting. So I show you some products created using laser cutting. So can we move on? So now comes the CNC milling machine. It's a 3-axis milling machine. നിങ്ങൾ കൊത്തുപണികൾ കേട്ടിട്ടുണ്ടോ? കൊത്തുപണി എടുക്കാന്ന് കേട്ടിട്ടില്ലേ? ഈ കൊത്തുപണി നമ്മൾക്ക് ഈ ഒരു ടൂൾ വെച്ചിട്ട് ചെയ്യാൻ പറ്റും. നിങ്ങൾക്ക് ഒന്ന് സൂം ചെയ്ത് നോക്കിയാൽ കാണാൻ പറ്റും കോർണറിൽ ഒരു മാനിന്റെ പടം കൊത്തി വെച്ചിരിക്കുന്നു. ആ മാനിന്റെ പടം നമ്മളൊരു സോഫ്റ്റ്വെയറിൽ ചെയ്ത് കൊടുത്തു കഴിഞ്ഞാൽ കൊത്തുപണി ഈ മെഷീൻ നമ്മൾക്ക് ചെയ്ത് കിട്ടും. ഇതേ മെഷീൻ കൊണ്ട് നമ്മൾക്ക് മൗൾഡിങ് ആൻഡ് കാസ്റ്റിംഗ് ഒക്കെ ചെയ്യാൻ പറ്റും. ഒരു വാക്സ് മോൾഡാണ് അവിടെ ഇരിക്കുന്നത്. ഒരു വാക്സ് ബ്ലോക്കിൽ ഈ ഒരു മെല്ലിംഗ് മെഷീൻ യൂസ് ചെയ്ത് മെറ്റീരിയൽ റിമൂവ് ചെയ്തിട്ട് ഇനി നമ്മൾ ഇതിൻ്റെ അകത്ത് പ്ലാസ്റ്റിക്കോ അല്ലെങ്കിൽ നമ്മളുടെ സിലിക്കോൺ മോൾഡോ ഒഴിച്ചു കഴിഞ്ഞാൽ ആ ഒരു ഷേപ്പ് നമ്മൾക്ക് കിട്ടും. പ്ലാസ്റ്റിക് പറ്റില്ല, യു വിൽ ഹാവ് ടു യൂസ് സിലിക്കോൺ മോൾഡ്. ഓക്കെ, സോ ഇതാണ് CNC മില്ലിംഗ് കൊണ്ട് ഉദ്ദേശിക്കുന്നത്. അതിന്റെ ഒരു വീഡിയോ ഡെമോൺസ്ട്രേറ്റ് ദ വർക്കിംഗ്. കണ്ടില്ലേ, CNC മില്ലിങ്ങിന്റെ അകത്തൊരു ടൂളിംഗ് ഒരു ബിറ്റ് ഉണ്ട്. ആ ബിറ്റ് വെച്ചിട്ട് അത് ഒബ്ജക്ട്സിൽ കൊത്തുപണികൾ ചെയ്യും, മില്ലിങ് ചെയ്യും. മീൻസ് മെറ്റീരിയൽ റിമൂവ് ചെയ്യും. ആവശ്യമുള്ള പൊസിഷൻസിൽ നിന്ന് മെറ്റീരിയൽ റിമൂവ് ചെയ്ത് അതിനൊരു കൊത്തുപണി പോലെ നമ്മൾക്ക് കിട്ടും. ഇതാണ് CNC മില്ലിംഗ് മെഷീൻ ചെയ്യുന്നത്. ഇതെല്ലാം റാപ്പിഡ് പ്രോട്ടോടൈപ്പിംഗ് ടൂൾസ് ആണ്. All of them are rapid prototyping tools.
Anuroop, I have a doubt.
Yeah, please.
Can we use this mechanism to spray something on a small substrate, like a glass substrate or something like that?
Yeah, it's possible. For that, you will have to, you can use the same mechanism and you will have to change the end effector. You will have to connect a sprayer, that's it.
That's it. Okay. Shall we? How can we set up a heating arrangement? Besides that, instead of that wood part, how can we set up a heating arrangement?
Heating bed.
Yeah.
Yeah. For designing heating bed, you will have to use Peltier modules. I hope you guys know about a Peltier module.
Can you type here in the inbox?
Sure. Is a personal message?
Yeah, after this session.
Yeah, I will send you a personal message and I will send you the link also.
Thank you very much.
You can purchase a Peltier module and you can create a heating bed. Otherwise, you can use a coil-based heating mechanism. So I will share that also.
See, what are the issue we are facing is that when the heating bed is placed there, the moving components will get affected by that heating.
Okay.
The components of the XY direction movements.
Okay.
By the heating. That's the issue we are facing.
Okay, so that we can solve. I will send the details in your inbox.
Okay. Thank you.
Fine. So can we move on?
Yes, please.
Okay. Next slide, please. So we talked about 3D printers. We talked about laser cutters. Now we are going to discuss about vinyl cutting. So I hope everyone knows about vinyl cutting. It's available in different shops. You can go and print different stickers using vinyl cutters. It will be in most of your cars there will be some sticker works. So everything is done using vinyl cutters. So why we are using it here? We are using it to print our logos of our product. You will go and print your logo, your product logo using vinyl cutter, and you will stick it onto your product. So that's why we are using vinyl cutters for branding purpose. Next slide. So that's all about the rapid prototyping tools. It's not a complete introduction. So we have very limited time. So the important tool, we have discussed about some important tools. So if you wish to have a 1 day long session, we will discuss everything in detail. Okay, so we are moving on to some consultancy projects which we did using these types of tools. So here is an automatic queue management system. This automatic queue management system is completely designed using the rapid prototyping tools available in our organization. So we designed this for Government Industrial Training Institute, Kalamesheri. So one of the designers is available in this meeting. His name is, let me introduce Mr. Gokul. He was also one of the designers of this particular product. It's an automatic queue management system which was delivered for Government Industrial Training Institute, Kalamesheri. They are using it there. So how did we manage to design this? So the product casing is designed using the laser cutter. the black thing, the black acrylic thing is designed using the laser cutter. And inside that, the electronics assembly and everything was prototyped using the Fab Lab facility available in our organization. And then we moved on to a final 3D print, final PCB print from Bangalore. Then we assembled everything. The product casing is completely designed using the laser cutter, and it is having a very good finish also. It's looking like a actual product. It's an actual product, but which is completely designed in Fab Lab. So that's all about the AQMS, which is prototype using laser cutter. The casing is prototype using laser cutter. Let's move on to the another project. So this is a Parkinson spoon, which was which was prototype using 3D printers, laser cutters, and some electronic production unit. The casing was initially printed using 3D printer, and we created this particular product. And this is a spoon which is used by the Parkinson's patient to have food easily. So we will show a video also. So that was a video of the prototype, our first prototype. Now it got evolved to something better. So you can see it here. This is a final version. So the video was about a prototype. So that prototype was completely created using 3D printing, and some molding here and there, some wax molding was also done. The majority of the parts was printed using 3D printer. And we got 50 lakhs funding from the central government for that particular product by RAC fund last year. So that's all about the Baltam Garage. Then we'll move on to the next product. So as I said, we are also working on software prototypes, and this is virtual event management platform. The virtual event management platform was designed during the COVID period for conducting virtual events, virtual expos, and we did the state government IEDC summit using virtual event management platform VEMP, and we did microprocessor challenge, central government microprocessor challenge using virtual event management flow. So we did almost 50 central state government using our product virtual event management platform. This platform was initially prototype using Adobe XD, and the 3D sessions was prototype using Play Canvas. And then we managed to design a product. So I will show you a quick video of the product virtual event management platform. Everything was prototype, so you can just watch the video.
The largest summit for aspiring entrepreneurs was hosted in virtual event management platform VEMP. The virtual summit was inaugurated by Sri T.K. Jose IAS, followed by the introductory remarks by Kerala Startup Mission CEO. The 3-day summit was packed with tech talks, panel discussions, and workshops by experts from various fields. The summit also showcased 3D virtual exhibitions where young entrepreneurs exhibited their ideas and products. Visitors had opportunity to chat and interact with exhibitors. Visitors and guests were taken into the virtual world, providing an immersive experience. The exhibition also promoted COVID-related products. In the closing ceremony, Vice Chancellor of Digital Science Varsity, Dr. Saji Gopinath, launched the initiative SMILE and announced the winners of challenges.
Project Director for Funding, Global Linkage and Evangelization, KSUM, Sri Riaz Mohammed, encouraged the budding entrepreneurs in the function.
The 3-day event had more than 1,000
So
virtual attendees.
that's
with
all
over
about our
29 speakers
platform.
and 20 plus events.
So this is a virtual event management platform. It was completely prototyped in our organization, and we managed to create a product from that particular prototype. So everything in a single platform. There is video conferencing in our platform, 3D product exhibition in our platform, virtual inaugurations, and everything in our platform. And now we are moving on to the metaverse. So we did an event with Blue Ocean Dubai recently, and we were their metaverse partners. And now we are on to the metaverse, and we are working with virtual reality, augmented reality, and mixed reality. And the platform supports everything. So if you have a virtual reality headset, you just use that headset and you can just walk through that particular atmosphere. You can feel everything. You will get a 360-degree feel of that particular expo. It will be exactly like an actual expo. And we got 12 lakhs fund from Kerala Startup Mission for implementing this particular thing. So we'll move on to the next product. So the thing, why I'm demonstrating all the products. So everything came from prototyping. We started with a minimal level prototype. Then we found some investors. Then we tried to apply for funding, and we attracted some fund. Then we proceeded with the final design, and now we have a product. So why? Because of the prototype. We made a prototype first. Then only we will get fund. Otherwise, nobody will come and support to create your final product. If you have a prototype, you will get fund. Otherwise, no fundings. So if you have an idea, try to create a prototype, and for that we will also help. So if you guys have any idea and if you wish to create a prototype, we will help. No problem. You can contact us through your faculties. We will help you designing everything. So please move on to the next slide. Okay, so this is a consultancy project which we did recently for Indian Navy. So I'm not gonna explain what exactly the product is, but I will tell you one thing. The prototype was made using laser cutters, 3D printers, and the electronic production unit available in Fab Lab. So this prototype was a success, and we got green signal to design this on a ship, on an actual ship. So let's move on to the next product. So this is a product which we are doing for Cyberdome, and this is associated with IIIT Kottayam. There is a faculty known as Ragesh sir. So he gave us an opportunity to design this particular thing. This is a trackable handcuff. So this is for the prisoners. You'll give a trackable handcuff for the prisoners, and we'll be able to track them completely. And this is a project which we are doing at present. Can we move to the next slide? So this is a smart inhaler, and this, compared to the normal inhaler, this inhaler has got tons of features. So this is prototype using 3D printers, vinyl cutters, laser cutters. All the prototyping machines are used here. Even the CNC milling machines are also used for prototyping this particular smart inhaler. Can we move to the next slide? So this is an IoT-based speed camera with number plate detection. Prototype using 3D printers, electronic production units, vinyl cutters, and everything is used for prototyping this particular thing. Moving on. So these are some of the designs products which we launched during the COVID period. Everything is prototype using the tools mentioned here. We have oxygen concentrators. We have automatic hand sanitizer dispenser Hygia, which is available in Amazon. You can go and purchase if you wish to have one. And we have pulse oximeters, and we have emergency buttons. All of them are market ready product, and everything was prototyped using the tools which I mentioned. Next slide. So this is an R&D project which we are doing with NDA. It's a wearable sensor. Using this wearable sensor, you can measure your body parameters, right? Temperature, heart rate, SpO2, and everything can be measured. This is an innovative design because the casing is fully biodegradable and the circuit is also biodegradable. Next slide. So here you can see we successfully designed a platform or a substrate which is able to conduct ink and it is fully conduct electricity and it is fully biodegradable. Next slide. So this is an IoT based plant health monitoring system and electronic production is used to prototype this. Next one. So this is a people counter, completely prototype using 3D printers and electronic production units. Next slide. So this is a waste segregator, which was prototype using laser cutters and 3D printers. We'll show you a video of prototyping.
Product which is able to segregate waste from a common pile of trash to different categories based on its characteristics and nature, making the waste suitable for proper disposal and easy recycling processes. First, the machine scans trash and identifies the various types of waste in it in a regular interval. It then collects the coordinate values of the identified waste and the arm moves to that location in the common trash. It then picks up the waste and moves it to the section where it belongs to. The hydraulic crushing and compressing mechanism enhances the storage capacity 10 times compared to the traditional ones.
Different phases of prototyping, from design to actual product. So this is electronic production. This is a laser cutting. The laser cutters was used to prototype the casing. See. And then we moved on to 3D printing for different parts. So the rail assembly was completely 3D printed. And we got a moving rail. Moving on to the phase 2. So here we are doing image processing. So now we got our mechanical structure and we are working on the image processing part and completely prototype using laser cutters and 3D printers. So
waste mode for handling all types of waste.
We successfully created a pick and place robot.
Solar-powered backup, hydraulic crushing for enhancing the storage capacity, and self-learning capabilities, improving the speed of operation and accuracy. The system also detects overflow of waste and crushes and compresses it to provide more space until it needs to be replaced.
Finally, the casing was done using printed using laser cutting. Then we did vinyl cutting for branding. See, the vinyl cutting was done using for branding purpose and indication purpose. So the waste segregator was ready. So that's all about the complete prototyping journey. So with this, I'm winding up the session. If you guys have any doubt, you can ask.
IoT and ML-based public trash.
So
yes.
Okay.
Thank you, Anuroop. Thank you very much for the informative and wonderful session.
Thank you.
Now the session is open for discussion. If you have any queries, you can ask, or you can type in the inbox. Students, faculties can also ask question, please.
So excuse me, myself Sabina, faculty of the college.
Okay.
I'm having a question.
Yeah, please, please.
So
You're not audible, ma'am. I'm not able to hear anything.
hello, sir.
Yeah. Now you're audible. Please proceed.
Okay, fine. So I'm having a general question. So our main problem is how could we get the funding for developing such prototype? Can you tell?
For prototyping, you don't need a huge funding. For creating a low fidelity prototype, you will cost 0 rupees. So from that prototype, you will have to attract funding. So when you're going for funding presentation or when you're going for an idea pitching, you will have to take your prototype, and the prototype will be a low cost one. You can go for a low fidelity prototype. It will cost 0 rupees, no problem. Once you have a low fidelity prototype, you can take it with you. Then you can attract the funding. Without prototype, attracting funding is very difficult.
Okay. So with that prototype, we'll have to go for this. We'll
Yeah,
have send.
definitely. Yeah, you will have to do something. The panel should think like that. Oh, he had done something great. So
Like
you don't need a perfect prototype. You just create a low fidelity prototype. That's more than enough for attracting funding.
Okay, sir. It was a very good presentation, sir.
Thank you.
You're from you.
So I will share my LinkedIn profile in the chat. So anyone wish to communicate, you can directly communicate. So any other doubts you can ask.
So if we need to get the funding, we need to produce a prototype first.
Yes. The most of the students they will come with an idea. So a simple idea won't do anything. You will have to create a very minimal level of prototype. If it is a working prototype, it's fine. Otherwise, it should be a low fidelity prototype. And cost is not a problem actually. If you're passionate about your design, you can go and design your prototype. It's not a problem. Actually, the prototyping is pretty cheap here. Even the electronic components are very cheap. You can create prototype under 1,000 or 2,000 rupees, no problem. If it is a low fidelity prototype, then you don't need to invest anything. If it is a software based product, you don't need to invest anything to create a prototype. Only if there is any hardware part involved, you will have to spend some money. Most of the ideas you can convert it to prototype under 2,000, 3,000 rupees. It's not a big deal actually. So we will also support if you guys have a very good idea, and if we are impressed, and we will fund for that particular prototyping, no problem.
Yes. Thank you very much for that. Okay. Actually, we are having some models. We have started an incubation center last year.
Oh, very good.
We have made some model, but we are unable to complete it. So okay. we are facing some technical difficulty to complete it because this is an arts and science college.
Okay.
So see, we are not so much expert in the field of programming and all.
Okay.
So yes, of course, we need your support to, I think, support to complete.
Sure. If it is a simple project, we can help with the fundings also. So actually, we are giving our service to other organizations also. No problem. We'll do 100% support on that.
So here I also welcome you for your physical presence here in future.
Sure.
So thank you. If there are no other questions, I think we can move to the concluding session.
Okay, fine. So I have shared my LinkedIn chat. So if anyone wishes to connect, you can connect with me directly, and I'll be happy to answer your queries. No problem.
Yes, thank you.
Thank you so much.
So I think we can move to the concluding session. I thank Mr. Anuroop for your wonderful presentation. It was highly informative, and it educated us a lot about the innovations and prototyping. Actually, we are not having much expertise in it. So I think your talk on it catered a lot to us. Thank you very much for that once again. And I thank Institution Innovation Council for the financial assistance of the program Impact Lecture Series for sanction Impact Lecture Series. And I also thank our principal, Dr. V.O. Amira, for the constant support and inspiration. And I also thank all the faculties, IAC members, and students. Thank you all. Thank you very much. Have a nice day. Thank you. So here the program is concluded. Thank you very much.
Thank you so much.